We live in an electric world, but what exactly is electricity? It all starts with tiny particles called electric charges. These charges come in two types, positive and negative. You can think of them like two sides of a coin. Opposite charges attract each other, just like the north and south poles of a magnet. Like charges, on the other hand, repel each other. This attraction and repulsion is what gives rise to the phenomenon we call electricity. Everything around us, from the air we breathe to the devices we use, contains these electric charges. Understanding how these charges behave is key to unraveling the mysteries of electricity. Electric charges don't just sit still, they can move, creating a flow of electricity called electric current. Think of electric current like water flowing through a pipe. The water molecules are like the electric charges, and the pipe is like the wire. What causes these charges to flow? It's the electric potential difference, also known as voltage. Voltage is like the pressure difference between 2 points in a water pipe. The higher the voltage, the greater the pressure and the faster the charges flow. Just like water needs a path to flow, so do electric charges. They need a material that allows them to move easily. This leads us to the concepts of conductors and insulators. Some materials are good at allowing electric charges to flow through them. We call these materials conductors. Metals like copper and aluminum are excellent conductors, which is why they're used to make electrical wires. Think of a conductor like a highway with many lanes. Electric charges can zip through these lanes with ease. On the other hand, some materials resist the flow of electric charges. We call these materials insulators. Rubber, glass, and plastic are good insulators. That's why they're used to cover electrical wires and prevent us from getting shocked. Insulators are like roads full of obstacles. They make it difficult for electric charges to move through them. Section 4. The role of different materials. The type of material affects how easily electric charges flow through it. This is because different materials have different atomic structures. Some materials have loosely bound electrons that can easily jump from one atom to another, making them good conductors. Other materials have tightly bound electrons that are not free to move, making them good insulators. The ability of a material to resist the flow of electric current is called its resistance. For example, copper has low resistance, so it's an excellent conductor. Rubber, on the other hand, has high resistance, making it a good insulator. Section 5. Temperature's effect on electric flow. Temperature can also affect how easily electric charges flow through a material. In general, as the temperature increases, the resistance of a conductor increases. This is because the atoms in the conductor vibrate more at higher temperatures, making it harder for the electrons to flow through. Think of it like this. Imagine trying to walk through a crowded room. If everyone is standing still, it's relatively easy to navigate. But if everyone is moving around erratically, it becomes much more difficult to move through the crowd. This is why some electrical devices get hot when they're used for a long time. The increased resistance causes more energy to be converted into heat. Section 6. The importance of electric flow in our lives. Understanding electric flow is crucial for our modern way of life. It's the foundation of countless technologies we rely on every day. Our homes are powered by electricity, which allows us to light our homes, cook our food, and power our electronic devices. Electric current is also essential for communication technologies like phones, computers, and the internet. From transportation to medicine, electric flow plays a vital role in countless industries and innovations. As we continue to explore new technologies, our understanding of electric flow will only become more critical.